Today we're going to talk about an AI that, well, it turns out it knew a little too much. And the secret it was hiding? It might just change how we build artificial intelligence from the ground up. All right, so take a look at these two images. On the surface, they're practically the same, right? It's the exact same chess piece, just parked in a different corner. So here's the puzzle. Should a normal, everyday computer vision AI be able to tell these two apart? And the answer is not just yes. It can actually pinpoint their locations with, get this, perfect accuracy. Now that should be impossible. And this one little fact pulls back the curtain on a huge secret about how AI really sees the world. This whole contradiction is so wild that the researchers who stumbled upon it called it, fittingly, the impossible puzzle. And they didn't mince words. In their paper, they basically called out one of the biggest assumptions in the entire field of AI, saying, we challenge this core belief that these AI models are translation invariant. So what in the world is translation invariance? It's actually a pretty simple but really powerful idea. It just means that a rook is a rook, whether it's in the top corner of an image or the bottom corner. The AI's ability to recognize that object shouldn't change just because its location does. This is supposed to be like a fundamental feature of convolutional neural networks, the CNNs that power almost all of modern image recognition. But something is clearly breaking that rule. So how is the AI doing this? How is it pulling off this impossible trick? Well, the investigation leads us to a really unexpected place, a tiny clue, hidden right at the very edge of the image. And here is the big secret. The AI doesn't actually understand top left or bottom right, not at all. It's cheating. It's found a subtle little loophole, a technical glitch that's created by the border of the image itself. Think of it kind of like this. The AI uses this digital magnifying glass, or filter, to scan across the image. When that filter is hovering over the middle of the picture, no problem. It gets a full, complete view. But what happens when it gets to the edge? Part of its view literally falls off into empty space. And the way it handles that off-the-edge moment is slightly different depending on if it's at the top, the bottom, or the side. This creates a unique signature, almost like a location fingerprint, and the AI has learned to recognize it. This diagram from the paper illustrates the problem perfectly. With some of the standard ways of processing an image, we'll call them the flawed methods, the AI effectively goes blind to the pixels that are right on the border. So the AI learns a clever trick. If it sees a rook but it doesn't get a signal from that specific pixel in the top left corner, then the rook must be somewhere else. It's figuring out the location by what it can't see. So now that we know the trick, we can name the actual culprits, the common, built-in methods that are letting the AI cheat with an object's location. The two main offenders are called valid convolution and same convolution. Now, we don't need to get bogged down in the math, but here's the key takeaway. These are not some obscure niche techniques. They are super common, standard issue parts in tons of the AIs that we all use every single day. And this isn't just a tiny problem happening right at the pixel-thin edge. The research showed that a really popular AI model could still guess an object's location with high accuracy even when it was over 100 pixels away from the border. That location fingerprint bleeds deep into the image, which makes this a much bigger deal than you might first think. Okay, so if the old rules are broken, what's the fix? Well, that leads us to a brand new rule for AI. Their researchers didn't just point out the problem, they came up with a really elegant solution. It's a method they call full convolution, or FCON for short. So what's the magic behind this new FCONV method? Well, just look at them side by side. The old, flawed methods lose information at the borders because of how they scan the image. But FCONV is designed specifically to make sure that every single pixel gets seen equally no matter where it is. This completely erases those location fingerprints at the border, which forces the AI to, actually learn what the object is, not where it is. All right, so we have a fix. But what does it actually get us in the real world? This brings us to our final section, building an AI that works smarter, not harder. To really prove how much better this new method is, the researchers came up with a really clever test. The AI's job seems simple. Look at these images and just say if the red square is to the left of the green one. But they set a trap. Here's the trick. When they were training the AI, every single time the red is left of green answer was correct, that pair of squares was always in the top half of the image. So the AI could learn the actual rule, red is left, or it could cheat and learn a shortcut. If I see something at the top, the answer is yes.
The real test then is what happens when you show it a red is left pair, but you move it to the bottom of the image. And the results are, honestly, they're staggering. Check out this table. The flawed methods look great at first, right? Almost 100% accurate when the squares are in the same old spot. But look what happens when you move them. The accuracy for the standard method just plummets to 8.4%. The other one drops to 0.2%. It's a complete and total failure. It learned nothing about the concept of left and learned everything about the location at the top. Now, look at the new method, FCON. Its accuracy is high, and, this is the crucial part, it stays high, whether the location is the same or different. It actually learned the rule, not the shortcut.
And this isn't just about avoiding clever tricks. This is about pure efficiency. On a smaller version of the huge ImageNet dataset, just swapping out the old method for FCON boosted accuracy by almost 7%. In the world of AI, that is a massive gain. It shows that when an AI isn't wasting its brainpower learning location shortcuts, it gets way better at its actual job. So why should you care about all this? It means that by fixing this one tiny seeming flaw, we can build AIs that are just fundamentally better. They become more robust, so they don't break when you just move an object. They are less likely to pick up on hidden biases in their training data, and they learn more efficiently, which is a huge deal when you don't have a lot of data to work with.
Which really just leaves us with one last kind of haunting question. This whole discovery was about an AI finding a clever shortcut that we, the creators, didn't even know was there. So if it can exploit something as basic as the edge of a picture, what other invisible loopholes, what other clever shortcuts are AIs taking right now that we haven't even thought to look for yet?